Okay, here we go. Final time of getting this one done. All right, I'm going to rewrite this as the limit as x approaches 1 of the cosine of pi x over 2 over, since this is squared to the 1/3 power, or cube root, I'm going to raise x minus 1 to the 2/3 power. Okay? But when I go do a direct substitution, well, I get the cosine of pi over 2, and we know the cosine of pi over 2 is 0. Plug in 1 on the bottom, I get 0. So I can therefore apply our friend L'Hopital. Okay, so I'm going to get the limit as x approaches infinity. No, 1. All right, so what's the derivative of this? Well, I know I get a negative sine of pi x over 2. And then the derivative of this is I get a pi over 2 out in front. So it's really negative pi over 2 times that. Okay, on the bottom, I get 2/3 times x minus 1 to the 1/3. And the derivative of this is 1. Sorry, that's negative 1/3. All right. Probably should simplify this on the bottom. We're going to actually end up simplifying it twice. So I get x goes to 1, I get negative pi over 2. I'm really not even going to touch the top. Then on the bottom, I get 2 over 3 times x minus 1 to the positive 1/3. Well, if I plug in 1, I get sine of pi over 2 is 1, so I get negative pi over 2. And on the bottom, I get 2 over 0. Well, I can't have a number over this, but I might be able to simplify it. So I'm going to flip the bottom to the top on this one, and I'm going to rewrite it, not applying L'Hopital's rule again, of negative pi over 2, sine of pi x over 2, and then I'm going to flip the bottom to the top, so it's times 3 times x minus 1 to the 1/3 over 2. Okay, so now when I do direct substitution, this is 1 times negative pi over 2. Okay, times 1. Now when I go plug in 1, what does this whole thing become? 0. When I multiply those together, I get what? 0. So that limit actually works out to be 0. So 0 divided by 0 in this case worked out to be 0. Is that always the case? No. Okay. All right, so let's look at number 14. We actually have an integral in this one. You're like, well, how can I apply L'Hopital's rule? Well, let's find out. So if I look at my limits here, if I'm substituting in 1, that's the integral from 1 to 1. Oh, well, that is an area of 0, correct? And when I plug in 1 on the bottom here, I get 2 minus 2, which is 0. So therefore, I can use my friend L'Hopital. Okay, so I'm doing the limit as x approaches 1. Well, how do I take a derivative of an antiderivative? Oh, wait a minute. The derivative of the antiderivative is just the function. But wherever I see t, what am I going to replace it with? Replace it with the x. So that numerator just becomes 4x minus 7. Okay. And then on the bottom, the derivative of that is just 2. Okay, so when I do direct substitution, I get 4 times 1 minus 7 all over 2 gives me negative 3 over 2. Okay? So I can apply L'Hopital's rule with an antiderivative. That still works. Okay? All right, so number 15. Let's look at 15. So if I approach 2, that's the integral from 4 to 4, which we know is 0. And if I plug in 2 on the bottom, I get negative, well, that's 2 squared. It's 2 squared is 4. Opposite of that is negative 4 plus 8 minus 4 is, in fact, 0 over 0, which is one of our cases. So I'm going to use L'Hopital. Okay. So I get the limit as x approaches 2 of, okay, a little tricky on the top. So the derivative of the antiderivative is just a function, but wherever I see t, what am I going to replace it with? 2x, and then I also have a chain rule on this at the end. So what do I get is I'm going to get 2x cubed minus 2x minus 60, and then that's all times 2. All over, now the derivative of the bottom is negative 2x plus 4, 2x. I'm going to simplify that top, okay, before I do anything. So if I go ahead and cube this, that's 8x cubed times the 2 is 16. X goes to 2. 16x cubed, because I distributed 2 to it also. Negative 2x times 2 is negative 4x minus 120 all over negative 2x plus 4. So now let's go substitute in 2. So 2 cubed is 8. 16 times 8. Well, I know 8 times 8 is 64 times 2 is 128. So I get 128 minus 8 minus 120. And then on the bottom I get negative 4 plus 4. Well, that's 0 is 0. So guess what I'm going to do? L'Hopital again. So I'm going to do the limit as x approaches 2 of, well, 3 times 16 is 48 x squared minus 4 all over negative 2. Now we're going to go substitute in 2. Well, I get 48 times 4 minus 4 all over negative 2. 96 doubles 192 minus 4, 92 minus 4 over negative 2. So what is that? 188 all over negative 2, which is negative 94. Okay? So we actually had to apply L'Hopital's rule twice to get our value here. The tricky part here was of course using the chain rule on it and making sure we remember to distribute it, because if you wouldn't have done that, you would have gotten half of this value, which is negative 47. So you got to be careful to make sure you include that in your derivative computation, okay, for this one. Okay, I hope this helps, and this wraps up the video series. Thank you.